All right, let's dive in. Today, we're talking about NoSQL databases. In a world that's just drowning in massive, fast-moving data, the old-school databases, well, they started to crack under the pressure. It became super clear that we needed a completely new way of thinking about how to store all this information.
So, this question right here, this is the exact problem that developers and data architects were wrestling with. I mean, just try to imagine cramming all the data from a massive social network or a huge online store into these neat, super rigid tables. It gets messy and it gets complicated fast. And that's exactly the challenge that NoSQL was created to solve.
Okay, so let's get into it. We're going beyond those relational databases, because really, the explosion of web apps, big data, and all these real-time services, it created challenges that the traditional databases, they just weren't built to handle. We needed a brand new approach, a totally new way of thinking.
And that new approach? It's NoSQL. The name itself, not only SQL, kind of gives the game away. It's not about throwing SQL out the window entirely. No, it's about having a powerful alternative for those times when a super rigid structure is actually more of a problem than it is a solution.
This chart here, it lays out the core differences perfectly. So with your traditional SQL, you've got this rigid, predefined schema. Think of it like a fixed blueprint for your data. NoSQL? Totally the opposite. The schema is flexible, it's dynamic, it can change and evolve. But you know what the real game changer is? It's scaling. SQL scales up, vertically, by just making one server more and more powerful. NoSQL scales out, horizontally, by just adding more keep servers. That is a way more sustainable approach when you're dealing with web-scale applications. All right, next up, a tour of the 4 NoSQL flavors. Because here's the thing. NoSQL isn't just one thing. It's a whole family of different database types, and each one has its own special strengths. I like to think of it like a toolkit. You wouldn't use a hammer for every single job, would you? Of course not. So let's check out the 4 main flavors and figure out how to pick the right tool for the right job. First up, we've got the simplest of the bunch, key value stores. Seriously, if you've ever done any programming, the idea of a giant dictionary or a hash map is, well, it's a perfect analogy. You have a unique key, let's say a word, and you have its value, the definition. That's it. It's really that simple. So what are these good for? Well, their number one strength is just blinding speed. I mean, databases like Redis and Memcached, they often get this speed by keeping all the data in super fast RAM instead of on a slower disk. And that makes looking things up almost instantaneous. It's all about simplicity and just raw, unfiltered performance. And this is exactly where they shine. Think about it. When you visit a website, it might store or cache data you use a lot in something like Redis. Why? To make the site feel incredibly fast and snappy. They're also perfect for things like tracking a user's session. Like what's in their shopping cart while they're clicking around an app. Okay, next up we've got document stores. This kind of builds on the last idea. Here, all your data is grouped into these flexible documents that, honestly, look a lot like JSON. So what does that mean? It means a single document can hold all the information about one thing. We're talking a complete user profile, with all its little nested details all tucked away in one single place. And the undisputed king of this category? That's MongoDB. It's pretty much the most popular NoSQL database out there, period. And its real power comes from that flexible schema. So for example, one user document might have a field for a middle name, but the next one doesn't. MongoDB, it handles that difference no problem, without breaking a sweat. This flexibility makes it just a perfect natural fit for things like content management systems, or maybe e-commerce product catalogs, where every item has slightly different features. And of course, for those detailed user profiles we talked about. Because you're storing all the related data together in one spot, reading it back is incredibly fast and super efficient. Okay, our third stop on this tour is wide column stores. Now, at first glance, this might sound a lot like the traditional tables and rows you're used to, but there's a huge twist. While the rows are defined, the columns are completely dynamic. You can almost think of it like a two-dimensional key value store, where every single row can have its own unique set of columns, and you can add them whenever you want. Databases like Apache Cassandra or Azure Cosmos DB, these things are absolute powerhouses. They're built for one thing and one thing only: massive, massive scale. I'm talking engineered from the ground up to be spread across hundreds, even thousands of servers. And they are amazing at handling a constant, heavy stream of new data coming in, what we call high write operations. So where on earth would you use something like this? Well, think about the billions of data points streaming in from all those Internet of Things devices, or the massive, massive log files that get generated by huge web services. When the sheer volume of data is just astronomical, wide column stores are pretty much always the answer.
And finally, we get to what might be the most unique flavor of them all, graph databases. Okay, so forget tables, forget documents. Graph databases are obsessed with one single thing: relationships. Your data is stored as nodes, which are the entities, the things, and edges, which are the actual connections between all those things. And this is where it gets really, really cool. You've definitely seen Amazon's "customers who bought this also bought" feature, right? Well, that's a graph database in action, mapping out all the relationships between different products. Or just think about Meta Social Graph. It is a colossal map of how billions of people are connected to each other. These are problems that are just absolutely tailor-made for a graph database.
So the key takeaway here is this. Whenever the connections between your data points are just as important, or maybe even more important than the data points themselves, well, that's when you need a graph database. Think social networks, recommendation engines, or even something complex like spotting fraud rings. In those cases, a graph database is going to be your new best friend.
Okay, let's talk about scaling. We touched on this earlier, but it is so fundamental to the whole NoSQL philosophy that we really need to dig in a bit deeper. And the best way to get it is with a simple metaphor. Think about the difference between building one single giant skyscraper versus expanding an entire city block.
So your SQL databases, they traditionally scale up. That's our skyscraper. You just keep adding more power, more CPU, more RAM to one single massive server. But eventually you hit a wall, both physically and financially. It gets crazy expensive. NoSQL, on the other hand, scales out. That's our city block. You just add more regular off-the-shelf servers to your cluster. This is usually done with a cool technique called sharding, which just automatically spreads your data across all those different machines. And this is what lets NoSQL handle a pretty much limitless amount of traffic.
But how is all this incredible scaling even possible? I mean, it sounds almost too good to be true, right? Well, it all comes down to a really fundamental design choice. It's a trade-off that every big distributed system has to make, a choice between having perfect consistency or having constant availability.
See, SQL databases live by something called the ACID principles. Think of it like a bank vault. They guarantee that every single transaction is perfect, and your data is always 100% consistent no matter what. Data integrity is the absolute top priority. NoSQL databases, though, they often follow a different model called base. Their priority is being basically available, making sure the system stays online, even if some parts of it are having a bad day. The trade-off for this uptime is something called eventual consistency. It means an update might take a little bit to show up everywhere, but the system guarantees it will get there, eventually.
All right, so after all that, which one is actually better? SQL or NoSQL? And the answer is, drumroll please, that's the wrong question to ask. It is never about which one is better. It is always about which one is the right tool for the specific job you need to get done. In this chart, this really drives the point home. If you're building a banking system, right, where every single transaction has to be perfect and data integrity is absolutely non-negotiable, you 100% want a traditional SQL database with those rock-solid ACID guarantees. But if you're building a massive social network or a super flexible e-commerce catalog, the sheer scale and adaptability of NoSQL makes it the clear winner, hands down. So as we wrap all this up, I'm going to leave you with this one question. Think about your next big project. What are you going to prioritize? Is it the strict structure and the guaranteed consistency you get with SQL, or is it the massive scale and the incredible flexibility of NoSQL? The good news is, now you've got the tools to make the right choice. Thanks for joining me.